The warning came without emotion. Target detected at extreme altitude, accelerating. High above the cloud tops, a pair of Soviet MiG-31s snapped into afterburner, their engines screaming as they clawed toward the edge of the atmosphere. Inside the cockpit, needles trembled. Temperatures spiked. Every limit on the aircraft was pushed to the red. But they had no choice. This intruder had appeared before, always on the border, always just out of reach. If they couldn't catch it today, they never would. The lead pilot shoved his throttle forward, feeling the aircraft shudder as it blasted through Mach 2, then Mach 2.5. The second MiG lagged behind, its engines already flirting with meltdown. They were close to the ceiling now, where the sky thins and the horizon curves, and then a flicker on radar. Altitude increasing, speed increasing. The intruder was simply rising away from them. The MiG pilot wiped condensation from his visor. "Impossible," he muttered as the blip pulled farther and farther ahead. The jet he was chasing wasn't just fast. It was untouchable. No missile could close the distance, no fighter could climb high enough, and no pilot in the Soviet Union had ever even seen it up close, because no one had ever caught it, not once. What made this aircraft so invincible? It wasn't one thing. It was a combination of physics, engineering, and Cold War desperation that no rival nation could match. The Cold War wasn't just a rivalry. It was a global contest where every inch of information mattered. Two superpowers, the United States and the Soviet Union, faced each other with enough nuclear weapons to end civilization. And both sides knew that whoever understood the other's intentions first held the real advantage. But inside the Soviet Union lay a secret world the West simply couldn't see. Thousands of kilometers of closed airspace were protected by a layered shield, surface-to-air missile batteries, early warning radar nets, and interceptor air bases stretching from the Baltic to Siberia. To the Americans, it was a black box, a place where new weapons, new missiles, and new doctrines were being built, without anyone in Washington knowing what was truly happening. So reconnaissance became more valuable than any bomb. Early U-2 flights offered a temporary solution. They could climb above 70,000 feet, higher than Soviet fighters or early missiles could reach. For a brief moment, the United States believed altitude was enough. President Eisenhower was even assured that Soviet radars couldn't detect an aircraft flying so high. But they could. They had been tracking the U-2s from the very first flights. And as Soviet technology rapidly improved, it was only a matter of time before one of those slow, fragile spy planes would be brought down. The illusion of safety disappeared. Altitude alone would never guarantee survival again. America needed something entirely different. Something the Soviets couldn't intercept, outrun, or even predict. Something no air defense network on Earth could stop. On May 1st, 1960, the Cold War's delicate balance cracked. A lone U-2 spy plane drifted above the Soviet Union, following the same routes it had flown for years. It was high, slow, and predictable, and this time, it wasn't alone. Below it, Soviet radar operators had been tracking its every move, coordinating a barrage unlike anything the US expected. A single S-75 surface-to-air missile arced upward through the thin air, then another, and another. At 70,000 feet, one of them found its mark. The U-2 disintegrated in a burst of smoke and debris, its pilot, Francis Gary Powers, ejecting into hostile territory. What followed was a propaganda coup. The pilot was paraded on television, the wreckage displayed for the world to see. Moscow declared it proof of US aggression. Washington scrambled to contain the fallout. It wasn't just a military failure, it was a humiliation. And it exposed the truth. The era of safe overflights was over. Soviet air defenses had caught up. Every future mission risked sparking a nuclear crisis. But what the world didn't know was that the replacement for the U-2 already existed. Hidden inside Lockheed's Skunk Works, engineers had been building something far faster, far higher, far harder to hit. Now, that secret project wasn't just important. It was urgent. The CIA turned to a familiar name, Lockheed's Skunk Works. This was the same secretive division that had built the U-2, a team known for doing the impossible with almost no time, no resources, and no margin for failure. But the requirements for the U-2's replacement didn't just sound ambitious, they sounded insane. The aircraft had to cruise beyond Mach 3. It had to fly above 80,000 feet, near the edge of space. It needed stealth. Years before stealth was even a real technology. It needed range, enough to cross continents. And it needed to survive future Soviet defenses, missiles and interceptors that didn't even exist yet. To meet those demands, Skunk Works engineers were forced into a world no aircraft designer had ever entered. At Mach 3, the skin of a jet doesn't just get warm. It becomes hot enough to soften aluminum like butter. Every panel, bolt, and fuel line would have to survive temperatures that reached 500 degrees Fahrenheit and more. At that speed, fuel behaves differently. Jet fuel can boil. Tanks can expand and warp. Everything becomes unstable unless engineered to perfection. And then there was the airflow. At Mach 3, air entering the engine doesn't act like air anymore. It hits with the force of a weapon, dense, violent, and unpredictable. One mistake in shaping the inlets, one miscalculation in the spikes or bypass channels, and the engines would tear themselves apart. Yet somehow, this small team of engineers looked at those demands and didn't say no. They said, "We can build that." From the moment it left the drawing board, the A-12 wasn't just another aircraft. It was something entirely new, an intelligence machine built to outrun, outclimb, and outthink every threat the Soviet Union could throw at it. It became the world's first true Mach 3 spy plane. To make that possible, Lockheed engineers had to abandon conventional aircraft materials. Aluminum couldn't survive the heat. Steel was far too heavy. So they turned to a metal almost no one in aviation had worked with before: titanium. More than 90% of the A-12 structure was made from it. But titanium was notoriously difficult to shape, weld, and machine. Entirely new fabrication methods had to be invented. Even the tools used to cut titanium had to be redesigned, because the metal was strong enough to destroy conventional equipment. Then there was the engine problem. At low speeds, the A-12's engines worked like standard afterburning jets. But once the aircraft pushed beyond Mach 2, the engines transformed. Air was no longer simply flowing in. It was slamming into the inlets with explosive force. So engineers created a system unlike anything before. The inlet spike, a long movable cone at the front of each engine, shifted backward as the aircraft accelerated. This controlled the shock waves, slowing the incoming air and stabilizing the engine. Below Mach 2, it behaved like a turbojet. Above Mach 2, it functioned more like a ramjet. At Mach 3.2, the A-12 skin reached over 500 degrees Fahrenheit. Its special black paint helped both dissipate heat and lower its radar signature. That black, angular alien silhouette, it wasn't designed to look futuristic. It looked that way because physics forced it to. The CIA's A-12 proved that Mach 3 flight was possible, but the Air Force wanted something even more capable. An aircraft that wasn't just fast, but versatile, reliable, and equipped to monitor an entire superpower from thousands of miles away. That aircraft became the SR-71 Blackbird. It was larger than the A-12, heavier, packed with more sensors, more cameras, more fuel, and far more sophisticated reconnaissance systems. Everything about it was scaled up, not for weapons, but for information. The SR-71 could cruise at Mach 3.2, not for minutes, but for hours. It flew so high that the sky outside its cockpit shifted from blue to deep violet, with the curvature of Earth clearly visible below. But to operate such a machine, the US had to create an entire ecosystem around it. Special KC-135Q tankers were built just for the Blackbird, capable of carrying its unusual high flashpoint fuel. Without them, the SR-71 wouldn't even reach cruising altitude. Maintenance crews learned to treat titanium like a living material, expanding in flight, contracting on landing, warping with temperature, and constantly testing the limits of metallurgy. Pilots trained for a world few humans ever experience: hypersonic airflow, rapid pressure changes, and navigation at altitudes where conventional aircraft simply can't survive. And yet, for all its complexity, the SR-71 had one simple goal: to gather intelligence without ever setting foot inside hostile airspace. From international waters, from the edges of borders, from corridors, the Soviets could only watch helplessly. The Blackbird could see hundreds of miles into forbidden territory. It didn't have to cross the line. It only had to fly near it. Once the SR-71 entered service, it didn't take long for the world to learn what it could do. It flew missions over North Korea, gathering intelligence on a peninsula permanently on edge. It crossed the skies above Vietnam, where dense jungles hid supply routes and missile sites. It orbited the Middle East, tracking conflicts that shifted by the week. Everywhere it flew, it left the same impression: nothing could touch it. Across decades of missions, more than 800 surface-to-air missiles were launched at the Blackbird. Not one ever hit. The reason wasn't magic, it was physics. Most missiles could accelerate faster than the SR-71, but only in short bursts. Their fuel burned hot, burned fast, and then they slowed. The SR-71 didn't slow. It flew at Mach 3+, continuously. It was the difference between sprinting and living your entire life at sprint speed. By the time an enemy radar locked onto the aircraft, the Blackbird was already 20, 30, even 40 miles farther along its path. Every missile fired at it was chasing a ghost, a target that had already outrun the engagement envelope before the missile even cleared the launcher. Interceptors tried too. The Soviet Union deployed its fastest jets, the MiG-25. They climbed until their cockpits frosted from the thin air. They pushed their engines to temperatures that risked tearing the turbines apart. They burned through fuel in minutes, not hours, but they could never reach it. Pilots described the experience with a strange blend of frustration and awe. They could see the blip on their radar. They could hear command shouting for interception. Yet the target kept rising, accelerating, slipping away, as if the sky itself was protecting it. For years, the SR-71 wasn't just fast, it was untouchable. For decades, people tried to point to one thing that made the SR-71 untouchable: its speed, its altitude, its stealth, its sensors, its technology. But the truth is far more complicated and far more impressive. It wasn't just speed. Soviet missiles could accelerate faster. Interceptors like the MiG-25 could spike past Mach 3 for a few desperate seconds. Speed alone didn't make the SR-71 invincible. What mattered was sustained speed. The Blackbird held Mach 3.2 not for minutes, but for hours. Nothing else in the sky could survive that long at that velocity. Everything chasing it slowed down long before it ever had a chance to intercept. It wasn't just altitude. Other aircraft could flirt with high-altitude flight. Some could reach 70,000 feet briefly. But the SR-71 lived there. It cruised in an environment where the air was so thin, even turning required planning miles in advance. Most aircraft simply couldn't function in that world. It wasn't just stealth. This wasn't stealth in the modern sense, but its black, heat-absorbing paint, angular surfaces, and carefully sculpted edges gave it a radar signature far smaller than any Soviet operator expected. Often they didn't see the SR-71 until it was already leaving. It wasn't just sensors. The Blackbird carried side-looking radars and long-range cameras capable of peering hundreds of miles into enemy territory, all while staying technically outside their airspace. The real reason no one could touch it. Everything worked together. Speed plus altitude plus stealth plus star sensors plus XAR's Cold War strategy. It wasn't unbeatable because of one miracle technology. It was unbeatable because it was the only aircraft in history where every system pushed the limit at the same time. That combination never existed before, and it hasn't existed since. By the early 1980s, the balance in the sky began to shift. The Soviet Union unveiled a new interceptor, one purpose-built to hunt targets like the SR-71, the MiG-31. It carried a powerful long-range radar capable of tracking targets at extreme distance. It fired R-33 missiles, designed specifically to hit high-altitude, high-speed aircraft. And unlike earlier Soviet fighters, the MiG-31 could climb high enough and stay high long enough to pose a legitimate threat. For the first time, the Blackbird wasn't alone in its domain. At the same time, the Soviets were rolling out newer surface-to-air missile systems. The S-200 and later the S-300 had longer reach, faster computers, and guidance systems designed to track targets traveling well above Mach 2. These weren't the clumsy missiles of the 1960s. They were modern weapons, closing the performance gap. Suddenly, the SR-71's margin of safety wasn't infinite anymore. American pilots began noticing tighter radar tracking. Electronic warfare officers saw more precise Soviet responses. And intelligence analysts warned that if the Soviets kept improving at this rate, the Blackbird's invincibility wouldn't last forever. For the first time in its career, the SR-71 faced enemies that could, on paper, catch it. And yet, even with these new threats, the Blackbird kept flying its missions. It didn't slow down. It didn't turn away. It simply kept doing what it always had, outrunning danger. But while the Soviets were building newer missiles, smarter radars, and faster interceptors, the biggest threat to the Blackbird wasn't the Soviets at all. For all the danger the Soviets posed, for all the missiles and interceptors built to chase it, the SR-71's greatest enemy was never another nation. It was itself. More than a third of all Blackbirds ever built were lost. Not to combat, not to missiles, not to fighters, but to accidents. At Mach 3, the aircraft behaved like a living creature. Its titanium skin expanded dramatically in flight, stretching several inches as it heated. On landing, as it cooled, those same panels shrank back into place, sometimes perfectly, sometimes not. Mechanics learned to check the aircraft like surgeons examining a patient after trauma. Even the fuel system was a paradox. On the runway, the SR-71 leaked fuel constantly, not because it was broken, but because the titanium panels hadn't expanded yet. Only at Mach 3, when the skin heated and the airframe swelled, did everything seal properly. And then there were the engine unstarts, a phenomenon every Blackbird pilot feared. When one engine's airflow suddenly collapsed, the aircraft would yaw violently, snapping sideways with immense force. At Mach 3, this wasn't just uncomfortable, it was deadly. Supporting the SR-71 required a massive infrastructure, special JP-7 fuel, dedicated KC-135Q tankers, dozens of ground crew, custom tools, custom procedures, custom training. Each aircraft consumed hundreds of millions of dollars per year to operate. It was one of the most expensive intelligence platforms in history. In the end, the Blackbird's limits weren't imposed by enemy missiles, but by physics, cost, and the brutal complexity of keeping such a machine alive. It could outrun the world, but it could never outrun itself. By the late 1980s, the world around the SR-71 was changing. Not because the Blackbird had grown weaker, but because technology around it had grown smarter. New generations of spy satellites could deliver near-instant images from orbit. They didn't need fuel, tanker support, or pilots flying at the edge of human endurance. They simply passed overhead and sent data straight to analysts on the ground. At the same time, early aerial drones were beginning to prove their worth. They couldn't fly at Mach 3, but they could stay in the air for hours, silently watching borders, bases, and conflict zones from above. And in Washington, budgets were being fought over inch by inch. The SR-71's breathtaking capability came with breathtaking cost. Hundreds of millions of dollars per aircraft, per year. Special fuel, special runways, special maintenance crews. The question wasn't whether the SR-71 still worked. It was whether America could justify paying for it. In 1998, after decades of service, the Blackbird was officially retired. 2 aircraft were handed over to NASA, where they continued flying research missions, gathering high-altitude data, and pushing the limits of aerodynamics one last time. The rest were grounded, silent, their engines cooled forever. A machine built to outrun everything finally met something it couldn't escape. Time. Even more than half a century after its first flight, the SR-71 still feels unreal. Not outdated, not primitive, not even old, just otherworldly. Nothing built since has matched its combination of speed, altitude, endurance, and elegance. New fighters can maneuver better. New missiles can track smarter. Satellites can see farther. But no jet has ever replaced the Blackbird. Not truly. Its capabilities weren't just ahead of their time. They were ahead of our time. The SR-71 became a symbol of what happens when pressure meets creativity, when a nation asks the impossible, and a small group of engineers decides to build it anyway. Its titanium skin, its needle-like fuselage, its long sweeping chines. These lines don't look like aircraft design. They look like science fiction sketches brought to life. A machine that came from a future we still haven't reached. Ask any pilot who flew it. Ask any mechanic who touched it. Ask any adversary who tried to chase it. They all describe the same thing, a sense of awe, a feeling that this aircraft wasn't bound by the same rules as other machines. Maybe that's why the Blackbird still lives on in museums, posters, novels, and imaginations. People don't admire it because it was fast. They admire it because it represents the absolute edge of what humans can create when they refuse to accept limits. The SR-71 was more than a spy plane. It was a message, A reminder that for a brief moment in history, we built something untouchable, and nothing since has come close.